YouTube. So today we'll continue our video series on BGP routing. The previous video we configured this part where we have the route reflector R4, R5, R6, and R9. R9 being the route reflector, and we tested, and we saw that there was full mesh BGP synchronization with all the other routers. So we can actually check right now. If we go to R6, okay, I actually made it command. If I go to R6, I do show IP BGP, show IP route BGP. Okay, we see we have on the perspective of R6, we can see a BGP route coming from router 1, router 2, or router 3, which is okay because the other routers are an iBGP, so we won't see BGP routes on router 6 from R4, for example. So in the same way, if we go to router 1, we should see BGP routes coming from all the other neighbors. So IP route BGP. Okay, so we see BGP routes coming from router 2, router 3, router 4, router 5, router 6. Okay. So yeah, so we have full mesh configuration so far. In today's video, we're going to configure this part whereby we want router 8 to be able to have BGP pairing with router 6. So we don't want to run BGP on router 7. Okay, so that's why you have this tunnel here. We have to create a tunnel. Okay, for that to happen, to be able to run BGP, to do BGP pairing between router 8 and router 6. Okay, so router 7 and router 8 have not been configured. In fact, I don't think I've configured this interface on router 6 yet. You can double check that. Gig 02, the 6, gig 02, we see if the interface is configured. So run interface gig 0/2. Okay, that interface is configured, but I think the other side is not configured. So which means if I do a ping 2.7, the same interface, I shouldn't have that working. Okay, it's not working because router 7 is not configured. So first of all, we're going to make sure that we have our initial configuration on router 7 and then on router 8. Okay, initial configuration, I mean just the interface configurations. Okay, router 7 and router 8. And if I go to router 7, show IP interface brief. Okay, there's something configured in the same way. Router 8, show IP interface brief. Okay, there's nothing configured. So what I'm going to do, I'm just going to add this initial configuration for router 7. Okay, just the interface configurations, and also the same thing for router 8, and then I'll come back. All right, so I went ahead and did the initial configuration for R7 and R8. We can actually check it right now. So show IP interface brief on R7. So these two interfaces are configured on R7. Okay, in the same way, do the same command here on R8. Okay, we're going to see all those interfaces are configured. So on R8, let me try to ping R7. It's going to ping the .7. Ping .7. Okay, ping is responding. But if I try to ping from R8, or try to ping .6, which is on R6, that ping should not work. Okay, it should not work, which makes sense because we have only configured just the interface configurations. But from R7, I should ping the R8. Okay, from R7, I should ping R6. Sorry, R6.6 here. So that ping is working. So what we have to do right now is to make sure R8 can have routing up to R6. Okay, so that R8 can ping this interface of R6. Okay, the gig 02 interface of R6. And to do that, since we don't want R7 to participate in BGP, okay, we don't even want to configure routing on R7 at all. What we're going to do is going to configure a default route on R7 and a static route on R8. Okay, in that way, R8 is going to know about this interface, about R6, through the default route is on R7. Okay, So let's go to R7. It's going to be configure terminal. So we're going to define the default route. It's going to be 192.168, and then we save that. And then on R8, we're going to configure a static route pointing to this interface of the of R7. Sorry, on R8, we're going to configure static route pointing on this interface of R7. Okay, this E11. Okay, so I'm going to go to R8, say configure terminal 92.168. Say that we have to go with the mask of 355.355.355.7. Okay, so what we're saying here is, if for R8, if you want to reach this interface on R6 with the subnet mask, okay, you have to go out, you have to point that traffic to the .7 that's on router 7. Okay, so we have to do the exact same thing on router 6, so that if traffic from router 8 hits router 6, it knows how to get back. So we have to do another static route 2 on router 6. Okay, so I'm going to go out of there, save this, and then I'll open router 6. Because if we don't do it on router 6, what's going to happen is router 7 is going to, let's say if you do a ping, the ping is going to hit the gig 002 interface of router 6, this interface. But router 6 is not going to know how to return that traffic, okay? How to return. So for that to happen, we have to configure another static route 2 on router 6. So this time it's going to be IP route 192.168.78.8, okay? With the subnet mask of 355.355.355.355, okay? For that, we have to define a gateway of 192.168, and then we save. Now from R6, if I do a ping from R6 to this interface of R8, okay, this interface serial 11 of R8, that ping should work, okay? So if I do a ping to 192.168.78.8, the ping is working. And the same way, if I go to R8, I do a ping from R8 to this interface gig 02 of R6, that ping should work as well. Ping 192.168, that ping is working. So now we have connectivity between R8 and R6, and we don't have routing here. So it's just by static routes. Now the next phase of what we have to do is to, since this, the reason why we have to create a tunnel at this point, even though we have connectivity between these two routers, is because we don't want this router to participate in BGP. And if you remember in our previous videos, BGP runs on TCP port 179. And if this router 7 doesn't participate in BGP, BGP updates coming from routers 8, okay, if we blindly define BGP PLN between R8 and R6, the port 7 is going to be blocked, port 179 is going to be blocked on this router, okay, because it won't be able to, it's not participating in BGP, so it won't be able to, it will block that port. So that's why we have to create a tunnel here between R6 and R8. That way, it seems virtually as though these two routers are directly connected because they have a tunnel running between them. So for the rest of this video, we'll be concerned now only with R6 and R8. Okay, we're going to create a tunnel. So let's start with R8. Say configure terminal, and we're going to define we're going to create a tunnel interface tunnel 0. Let's call it tunnel 0. We define a tunnel source IP address, tunnel source, and we'll give that source as 192.168. And we'll give tunnel destination. Tunnel destination is going to be this interface of R6, which is 192.168.7.6. Okay, that's a destination. And then now we're going to create our tunnel destination. Tunnel destination is 192.168. And now we're going to create an IP address, IP Give an IP address to the tunnel, which is going to be 192.168.255.255.255.0. Okay, and if you remember very well, the scheme, our IP addressing scheme is, if you see on the 10th octet 68, it means we're trying to link two routers, router 6 and router 8. Okay, that's what the meaning of this 10th octet 68 here. So we're going to do the same thing on the other side, and then I'm going to go to R6, configure terminal, IP interface tunnel 0. Okay, and then I'm going to give tunnel source. Tunnel source is going to be 192.168.67, 192.167. Then I'll get IP address. IP address of the tunnel is 192.168. Okay, with subnet mask 355.355.2. Okay, let's save this. Now that we have our tunnel configured, it's time to define a static route between R8 and R6. And that static route is on the tunnel, okay, with a tunnel. So which means on R6, our static route is going to be pointing directly on the interface, on the tunnel interface for R8, okay. So it's going to be configured terminal. Okay, just a little bit of a recap before I give the put the static route. So what we've done so far is this router 6, router 8 can actually reach router 6, okay. But since we don't have dynamic routing yet configured between R8 and R6, the loopback interfaces of both routers cannot talk to each other. So our static route on the tunnel is going to say, okay, if router 8 wants to reach the loopback interface of router 6, okay, it has to be pointed to the tunnel interface of router 6. Okay, that's why we are creating a static route at this point. Okay, we just want to make sure that the loopback interfaces of router 8 and router 6 are able to see each other, so that we can be able to define them in BGP, in our BGP routing. Okay, so that's why here on router 6, I'm going to say IP route 8.8.8.8, which is on router 8. Okay, so it's going to be with subnet mask of 355.355.355. I'll say pointing to 192.168. That's for router 6. I'm going to do the same thing for router 8, pointing on the loopback interface of router. I'm going to do the same thing on router 8, pointing on the loopback interface of router 6. Okay, so it's going to be the terminal IP route 6.6.6.6. Okay, the subnet mask of 355. Okay, it's going to be 192.168. After there, we're going to save. I don't know if I saved here. So we'll go to save. Now, what I'm going to do, I'm just going to ping the loopback interface of router 6 from router 8. Okay, if I do a ping to 6.6.6.6. Okay, crossing from my loopback interface. The ping is working. Okay, so the ping is working, and I didn't put this command, but I should also show interface tunnel 0. Okay, our interface is up. I didn't check that with the command. Show it tunnel interface just to be sure that our interface is up. So basically, right now we are set to configure BGP routing between routers 8 and router 6. As you can see, I have not yet, on router 8, I have not yet added this other loopback interfaces. These ones, I'm going to inject them into BGP directly. So as long as we have connectivity, full connectivity from the loopback interface of routers 8 to router 6, now we know we can now configure BGP between these two. Okay, the BGP pairing between these two will work. And then I'm going to define these ones in the, I'm going to inject this loopback interface in the BGP. So let's configure BGP on router 6, router 8 pointing to router 6. So it's going to be configure terminal. Network is 8.0.0.0. Okay, that's our loopback interface. And then define a neighbor. So now we can define the neighbor, the loopback interface of router 6, which is 6.6.6.6. Okay, and then we'll define the same neighbor, say eBGP. Because now we have eBGP. Okay, eBGP multi-hub. Let's give 4 this and say update source loopback 0, and that's it. Take this, go to router 6, and then remote AS is eBGP multi-hub. Let's give 4. Okay, and we define this as update source. Update source is going to be loopback 0. Okay, so what's left for us to do right now is to inject this loopback interface of router 8 into eBGP. Okay, but before doing that, let's just test and be sure that they will have BGP. We already can see that there's BGP neighbor relationship. Okay, just came up. So let's check the show IP BGP summary. Okay, so the neighbor is up. It's providing us 14 prefixes. Okay, so our neighbor is up and providing us 14 prefixes. We can actually check what are those prefixes. We can do show BGP IPv4. Okay, no, not this one. Unicast, let's see, 6.6.6.6. Okay, routes. Okay, so these are this should be the 14 prefixes that are receiving from router 6. Okay, so if you count them, there should be 14 of them. Okay, 14 prefixes, and so we have BGP. The router 8 is receiving those BGP routes from router 6, and if on router 6 we don't yet have this interface, this BGP, these loopback interfaces of router 8 are not yet getting to router 6 because we haven't injected them yet. We can actually check them. Do show IP route BGP. Okay, so you see these ones are coming from router 1, but we don't see yet these ones. I need to I'll put those ones. I will add them on router 8. So we can also see we have BGP routes, the 8 network. Okay, that's the loopback interface of router 8. You can see that in our BGP table, and we can ping it. Ping 8.8.8.8. Okay, so 6 from our loopback. Okay, that ping is working. So what we're going to do right now, we're just going to go to router 8 and inject these loopback interfaces into our BGP. So to inject these loopback interfaces on router 8, instead of just adding them manually, one line after another on router 8 BGP configuration interface, I prefer to use a route map. Okay, I used so what I'm using here is right here at the left. See access list 1, permit 10.440.0.0, then followed by the wildcard mask. Okay, 0.0.255.255, which represent the /16, and then this one 0.0.127.255 represent the /17. And if you really want to know how, I used online tool to calculate this. So if I go online, see, let's I put this one, and then I define this as /16 subnet calculate. Okay, so that's how I got those okay, the first IP address. I'm using the first IP address. All right, and that's this is the subnet mask right here. Wildcard mask is here. The subnet mask is right here. So that's how I did to define this access list. Okay, So now the access is defined for all the subnets on router 8, and now after that I put the route map. I call the route map pnets, and then I want to match the IP address. I want to match the IP address with access list 1. Okay, and then on the BGP, okay, I applied it using the redistribute command. Okay, I'm just going to copy and paste. Copy this and paste on the router 8. That way we're going to have our BGP injected with loopback interfaces. I'm going to say configure terminal. And then I'll just add this one. Hopefully we don't get any error. Okay, we save. Now if I go to router 8, router 6, I do show IP route BGP, or maybe show BGP IP unicast or neighbor or unicast. Okay, neighbor is 8.8.8.8. Okay, routes. So we're finding on router 6. What this command does is it's trying to find on router 6 what are the prefixes that are received on router 6, okay, from this neighbor. Okay, so if I do enter, so you see it's receiving those prefixes that we just injected. You see the /16, /17, /20, /20. So which means on this router now we can actually ping. Try to show IP BGP. Okay, from this router, from router 6, we should now be able to ping this one. Let's say this is coming from router 1, so let's ping this one instead. Coming from router 8, ping. Okay, see that ping is responding. So we have full mesh. We have full mesh, and we continue doing more and more tests, but I wanted to stop this for today. And then, so what we have right now on router 8, we have full mesh BGP synchronization with all the other routers. We can actually go on router, because now right now we just tested on router 6, but let's go on router 8 as well and test. So router 8, show IP BGP unicast neighbor. Okay, just to see what routes we're getting. Okay, routes. Okay, we're getting all of that, which means we can actually ping. We can ping 1.1.1, and we can do a trace route as well. Trace route to 1.1.1.1. Let's see how that route is. Let's see the routes. Let's see the trace route from router 8 to router 1. Okay, let's see the trace route going through router 6. All right, so our trace route unfortunately is not working, but at least the ping is working, which I'm going to find out why the trace route is not working. But at least if I do a ping, ping is working. If I ping, I'm going to figure out exactly why trace route is not working. Okay, if I do ping to 2.2.2.2, back is working. If I go to router 1, let's see if I'm seeing this prefixes coming from router 8 on router 1. I'm going to go to router 1. If I do show IP route BGP, okay. Yeah, we do have them. We have these prefixes coming in. These are prefixes coming in from router 1, okay, from router 8. We see they're coming through router 4. So if I do a ping from router 1, I don't know why the trace route is not working, but I'm going to figure that one out. Okay, source from the back 0. Okay, that ping is working. All right, so this is all for this video. I don't want to make it much longer than this. In the next video, what we're going to do is just going to add this one. It's going to be a much shorter video. We're just going to add this ISP router, okay? And then we will define what that ISP, how we're going to route traffic between router 8 and and the ISP router. Okay, so that's going to be a short video for the next one, and for this one, that's all. Thanks so much for watching, and talk to you in the next video.